Welcome back to my walkthrough of the Sonic Pi tutorial. In this video, I'll be going through section 1.2, exploring the interface. So, here it is. The Sonic Pi interface. Sonic Pi has a very simple interface for coding music. Let's spend a little time exploring it. There's a diagram here, but I'm going to skip ahead to the text and I'll point them out with my shiny mouse highlighter as we go. Okay. A. Play controls. These pink buttons, well, they're gray buttons in my setting, so oh well. These buttons are the main controls for starting and stopping sounds. There's the run button for running code in the editor, stop for stopping all running code, save for saving the code to an external file, and record to create a recording, a WAV file of the sound playing. Next we have editor controls. These orange buttons, again they're gray here, they may be orange on your screen. These buttons allow you to manipulate the code editor. The size plus and size minus buttons allow you to make the text bigger and smaller. C. Info and help. These blue buttons give you access to information. Again, gray buttons here, oh well. Help and preferences. The info button will open up the information window, which contains information about Sonic Pi itself, the core team, history, contributors, and community. Let's pull that up now. Sonic Pi, the live coding music synth for everyone. Designed and crafted by Sam Aaron in Cambridge, England. So there you have it. The help window is open now. It says the help button toggles the help system, G, and the prefs button toggles the preferences window, which allows you to control some basic system parameters. I'll go ahead and open that up now. You see we've got main volume. I'll actually lift it a bit from where it was. D, code editor. That's this area. This is the area where you'll write your code and compose/perform music. It's a simple text editor where you can write code, delete it, cut and paste, etc. Think of it like a very basic version of Word or Google Docs. The editor will automatically color words based on their meaning in the code. This may seem strange at first, but you'll soon find it very useful. For example, you'll know something is a number because it's blue. E is the Prefs Panel. I guess I kind of already went through that, but Sonic Pi supports a number of tweakable preferences which can be accessed by toggling the Prefs button in the Info and Help button set. This will toggle the visibility of the Prefs panel, which includes a number of options to be changed. Examples are forcing mono mode, inverting stereo, toggling log output verbosity, and also a volume slider and audio selector on the Raspberry Pi. The Raspberry Pi? Huh. I don't know. I'm not using a Raspberry Pi. Anyway. F, log viewer. That's over here. If you can read this well enough, it says setting main volume to 0.95 and so on. When you run your code, information about what the program is doing will be displayed in the log viewer. By default, you'll see a message for every sound you create with the exact time the sound was triggered. This is very useful for debugging your code and understanding what your code is doing. Excuse me. G, help system. One of the most important parts of the Sonic Pi interface is the help system. That's this whole area here, which appears at the bottom of the window. This can be toggled on and off by clicking on the blue help button. The help system contains help and information about all aspects of Sonic Pi, including this tutorial, a list of available synths, samples, and examples, FX, and a full list of all the functions Sonic Pi provides for coding music. I may go through that a little bit more at the end of this video, but I'm going to bravely continue on through the sections. H, scope viewer. That's up here. The scope viewer allows you to see the sound you're hearing. You can easily see that the saw wave looks like a saw, and the basic beep is a curvy sine wave. You can also see the difference between loud and quiet sounds by the size of the line. There are 3 scopes to play with. The default is a combined scope for the left and right channels. There is a stereoscope, which draws a separate scope for each channel. Finally, there is a, oops, I don't know how to say this word, but I'm going to give it a try, Lissajous curve scope, which will show the phase relationship between the left and right channels and allows you to draw pretty pictures with sound. Apparently, you can look that up on Wikipedia if you want to. The Q viewer. Here's Qs. All internal and external events, called Qs in Sonic Pi, are automatically logged in the Q viewer. For example, if you have a MIDI controller connected and press one of its buttons, you'll see a new Q event in the Q viewer telling you the name of the controller and which button you pressed. Once you've mastered the basics of making and producing sounds, you'll start to want to cue sounds or whole section of sounds based on events such as these. A Q event is just an indication that something happened. For example, every time a live loop spins round, it sends a Q event out, which is logged in the Q viewer. Also, external events such as MIDI messages from connected MIDI equipment and OSC messages from other programs or computers are also displayed in the Q viewer. It is also possible to directly generate Q events using the Q function. Anything that appears in the Q viewer can be used to trigger something happening. This is covered in more detail in sections 10 to 12 of this tutorial. Well, that's good, because I was going to say that's getting a little verbose without me going into any examples of it. But let's continue on down the... that's the end of it. Let's go back up and explore a little bit through the help system. Again, that's available from the help button here. How about examples? Haunted, Apprentice, coded by Sam Aaron, same person who made this whole program, if you're paying attention. Let's try dropping that into the main buffer and see how it sounds. Let's notice some things about the interface here. We can see sounds happening all along there. We can also see that live loop Haunted keeps getting queued. You know, I think I'll do a whole video on just the examples, but that's enough for now of that. We can see that there are synths. Let's play with that a little bit. Okay, syntax fail there. I'll do that in a later video. But we see that there's brown noise, chip lead, chip noise, C noise, various things. We have effects like auto tuner, oh that'll be fun, bit crusher, distortion, samples like ambient sounds, drum sounds, electric sounds, then language, what's this, assert. This looks like it's keywords that you can use when we get into more serious programming. Not something we'll be doing in this one. So I'm going to leave you with one more example. Oops. Need to copy this one. No. Copy. There we go. Let's listen to this example and then we'll call it a day on this video. Okay. Thanks for watching. Oh wait, I have to press stop.